Review, I'm going to do the number 1, and let me go ahead write the formula for that. So we're finding 2/5 of the way between 2, 4, and 12, 19. So the formula would be x1 plus k, x2 minus x1, and then the same formula, y1 plus k, y2 minus y1. So I'm going to go ahead and label x1, y1, okay, x2, y2, and then 2/5 would be my k. So I'm going to plug everything in, x1 plus 2/5. x2 is 12 minus x1, which is 2. So 2 plus 2/5 of 10. That's going to be 2 plus 20 divided by 5 is 4, so 6. And then y1 is 4 plus k, which is 2/5. y2 is 19 minus y1, which is 4. 4 plus 2/5 of 15. So 2 times 15 is 30. 30 divided by 5 is 6. It's going to be 10. So the point that is 2/5 of the way between 2, 4, and 12, 19 is 6, 10. Okay. So the next thing I'm going to do is I'm going to do the finding the endpoint given to midpoint. So let me erase that. Okay, so the formula I'm going to use here is going to be the midpoint formula. Okay, but I'm going to add something to it because we're looking for endpoints. So I'm going to call this x1, y1, and call this mx, yx, or sorry, my. Okay, let me zoom in. So there's more room here actually because I write kind of big. Okay, so I'm going to say mx equals x1 plus x2 divided by 2, and my equals y1 plus y2 divided by 2, and I'm going to fill my stuff in. Okay, again, x1, y1, and then call that mx, my. Okay, and I'm calling those mx, my because that's the x value of the midpoint and the y value of the midpoint. So -2 equals x1, which we decided, or which I decided was -5, plus x2 divided by 2. My is 2 equals y1, which is 7, plus y2 over 2. Okay, so I'm going to multiply both sides by 2. So that gives me -4 equals -5 plus x2. Okay, I'm going to add 5 to the other side. So I get 1 equals x2. Okay, and then finish up on this side, multiply both sides by 2. Okay, so that'd be 4 equals 7 plus y2. Okay, those cancel. I'm going to subtract 7 from both sides, so I get that y2 equals -3. Okay, so that means my point B is 1, -3. That's my other endpoint. Okay. Okay, so this is going to be a segment bisector. That's a construction for a segment bisector. XY, or segment XY bisects PQ. Okay, so that means that XY is perpendicular to PQ, creates 90-degree angles. Also, PJ is congruent to j cubed. All right, so number 5, I'm going to find the perpendicular line. Okay, so I know that the perpendicular slope, so I'll find the perpendicular for 5 and then the parallel for 6. Okay, so the perpendicular slope, okay, so perpendicular slope of this particular line is negative 1/3. Okay, let me make this bigger so I can... Okay, and then the formula I'm going to use is that y minus y1 equals m times x minus x1. Okay, this is x1, that's y1. Okay, y1 is 4, m is negative 1/3, x1 is 1. Okay, I'm going to distribute that 1/3 in. So y minus 4 equals negative 1/3 x plus 4, no, 1/3, excuse me. Okay, it's a little smushed in there. Okay, so then I've got y. I'm going to add 4 to y minus 4. Let me go ahead and rewrite it because it's very, like, smushed in there, and I don't really have good handwriting to begin with, so here we go. X plus 1/3. So I'm going to add 4 to both sides. Okay, that should be a minus. So add 4. I'm going to find a common denominator. Okay, so my solution is negative 1/3 x plus 13/3. Okay, so there's that one. Okay, number 6, I'm like running out of room here for that one, but let me see. How can I do number 6? Okay, so y minus, okay, we'll call this x1, y1, and my m remains the same. So y minus y1, so I'm using the same formula as right here. Okay, y1 is 3 equals negative 2 times x plus 2. Okay, so y minus 3 equals negative 2x minus 4. I'm going to add 3 to both sides. Okay, so the solution for this one, and let me, y equals negative 2x minus 1. Okay, so this one I did parallel, this one I did perpendicular. Okay, so how are perpendicular slopes related to each other? They are negative reciprocals. Okay, so my undefined terms are point, line, plane. Okay, my point, well, that's a point, okay? P, we could say point P. Okay, line is, okay, let's call that line AB. Okay, and then the plane, X, I don't know, let's call it XYZ. Okay, I'm going to redraw that because that's pretty rough there. Okay, collinears on the same line. Coplanar, points on the same plane. Okay, so it says find the value of x. Okay, so 180 is total because those are a linear pair, so that makes this one 70. Okay, and then if I use this entire triangle, this is 90. So if I do 180 minus 90 minus 70, x will equal 20. Okay, that's a quick way to do that one. Complete the table. Okay, so this is P to Q. Converse is Q to P. Okay, so the converse would be if measure of angle C is equal 50 degrees, then angle C is acute. Okay, that would be true. Okay, but if angle C is acute, then it's 50 degrees. That is false because it could be something else besides 50 degrees. Okay, it could be 60 degrees. Okay, and actually that would be a counterexample. If I go down here to the bottom, that would be a counterexample because what if angle C is 60 degrees? Okay, so that would be my counterexample from what's up there. So I can't do biconditional because I have that the converse, the conditional and the converse are not both true in both directions. To do the biconditional, they have to be true, both of those, the converse and the conditional. Okay, so this not P, not Q. Let me rewrite that. If angle C is not acute, then measure of angle C is not 50 degrees. Contrapositive, not Q, not P. Okay, I would do it in a different color. If measure of angle C is not 50 degrees, then angle C is not acute. Okay, so line P is all right, so let's draw this. So it says line A, here's line A, is parallel to line B. Okay, we know this because it says it there. Okay, line B is parallel to line C. Okay, so I'm making the blue ones parallel to each other. And then line D is perpendicular to line A. Let me redraw this up here a little bit because it's a little bit crowded. Perpendicular. Okay, so if those are perpendicular, if A is perpendicular to C and all of these are parallel to each other, then that means those are also perpendicular. Okay, so D is also perpendicular to B. That is true. A is parallel to D. That is not true. Okay, C is parallel to D. That is not true. B is parallel to C. That is true. And then D is perpendicular to C. That is also true. Okay, let's look at number 12. Okay, so AOC, this whole thing is 97 degrees. Okay, but I do know that this angle bisects, or this segment, or this line, or this ray, bisects EOC, meaning this equals to this. Those two halves are equal to each other. So to find what DOE is, one of the x's, I'm going to do 180 minus 97 and then divide that by 2. So that gives me each of those halves. Okay, so 180 41.5. Okay, so x is 41.5. Each of these halves is 41.5. Okay, so draw two examples of 3 points that are coplanar, but not collinear. Okay, so that's a plane that's coplanar but not collinear. And another example would be like a linear pair. 3 points that are coplanar but not collinear. Okay. Okay, so it says which one of these is true? Okay, so I know that this is 130. Okay, so if these two are corresponding, the angles C and E are parallel to each other. Okay, that's the only thing that we really are getting that makes any sense. So 120, yeah, like, okay. And then finally, okay, this is 3x minus 2. This part is 2x minus 5. Okay, and then those two added together equal 180 degrees. So 2x minus 5 plus 3x minus 2 equals 180 degrees. So I'm going to add together 3x plus 2x, which is 5x, minus 7 equals 180 degrees. I'm going to add 7 to both sides. So 5x equals 187. Divide both sides by 5, so x will equal, let me get what that number is, 37.4. Okay, so I do know that CKS angle, measure of angle CSK, excuse me, is congruent to the measure of angle LRB. Okay, so if I take this 37.4 and plug it back into the 3x minus 2, that will be what the actual measure of CSK is. So I get 72.8. Okay, so this measures 72.8.